Hi everyone, and welcome to Adding Rational Numbers lesson 2.2. Write that at the top of your composition notebook page that you're on. The essential question today is how can you use what you know about adding integers to add rational numbers? And by the end of this lesson, you should definitely know how to answer that. You'll probably figure it out along the way. Okay, so the first thing we want to do is write fractions in simplest form. So these are all adding problems. I'm going to take a pencil and we're going to do this. I don't like that this is an improper fraction, a mixed number. So I want to make it an improper fraction. So 3 times 9 is 27 plus 4 all over 9. And then that equals 31 over 9. Then I have to bring the rest of the problem back down here. So plus negative 2 thirds. Okay, so I see that these are different denominators, and I want them to be the same because in order to add and subtract fractions, we want the denominators to be the same. And then we only have to worry about the numerators when actually adding or subtracting them. So I know that 3 is a multiple of 9, so I'm going to multiply this fraction by 3 over 3 because that's going to give me the denominator to be 9. And so now I get 31 over 9 plus negative 6 over 9. Because that is negative 2 times 3 equals negative 6, and 3 times 3 is 9. Okay, I'm going to erase this just so we have more room to do things. Okay. Here we have a positive 31 and a negative 6. So we're going to use our DS integer rules because if you're just looking at 31 and negative 6, those are just integers. So 31 minus 6, because if you have different signs you need to use subtraction, gives us 25. 31 is larger than the negative 6, so we're going to keep the sign, we're going to take the sign of the positive number. So that is going to equal 25, and then that denominator that we made earlier. And this is what we want. You can make it a mixed number if you would like, but this is a simple form in an improper fraction, so you could leave it like this, and I would be happy with that. Okay, so now I'm going to skip these because this is number 2 and 3 are very similar to number 1, and we're going to go ahead and look at number 4. So when I look at this, I get confused. There's decimals. I don't like that. So I'm going to make it a fraction by looking at the placement of the decimal point. So this is in the 10th place, the 0.3, that's 10th place. And so is this 0.4. So then I can take out that decimal and write it like negative 123, and then just divide it by that 10th place. And then plus 54, because I took out that decimal, and that is divided by that 10th place. Okay, so I have a negative 123, and I have a positive 54. Again, I'm going to be using the different signs. So I have 123 minus 54. That equals 69. And I'm going to use that denominator that we have that's the same, put that over there, and that gives me the 69 over 10. But I need to look at signs. I have to take the sign of the larger. The larger in this case is a negative. So it's negative 69 over 10. This would be a correct answer. However, since the question was given in a decimal form, we should probably write the answer in a decimal form. So our answer is actually negative 6.9. And we're good. So please do the rest of these on your own. And go ahead and write this in your composition notebook. So adding rational numbers. To add rational numbers, use the same rules for signs as you use for integers. So yay! Like I said, we use the different signs here. And so you can also use same signs and add up to the top because, again, the numerator numbers are just integers. Okay. And this one is very easy to do, so I'll just let you do that on your own. You just need to make, again, you need to make the denominator a 6, so you're going to have to multiply the top and the bottom by 2, and then you use different signs to determine what the numerator is and simplify. Here is also even more practice. Again, I think that you guys are able to do this on your own, and if you have any questions, please let me know. You're going to have to divide these two by 100 instead of 10 because they're both in the 100th place. This one's in a 100th place and this one's in the 10th place. So you're going to have negative 815 over 100 plus negative 43 over 10. So you're going to want to make these denominators the same. You do so by multiplying this side by 10 over 10, and then you just add. Okay, so now we have evaluate 2x plus y when x equals 1/4 and y equals negative 3/2. So we're going to have to plug the x where they say to, which is 2 times x, and then right there for the y. So we have 2 times the x, which they say is 1/4, and then plus the y, plus the y, which they say is negative 3/2. Okay, and then from here, I'm just going to draw a 1 under there so I can see I'm going to be multiplying right across. So 2 times 1, 2, over 1 times 4, 4, plus negative 3/2. Sorry, I don't know why I keep writing it like this. I should be writing it like this, but okay. I see that this isn't simplified, so I'm going to go ahead and simplify that. That equals 1/2, because 2 goes into 2 once and 2 goes into 4 twice. And then plus negative 3/2. Again, these are different signs. So 3 minus 1 gives me 2. Take the sign of the larger, which is the negative 3. So that equals negative 2 over 2. And that gives me negative 1. And that's our answer for that one. Okay. Okay, and this problem is very similar to the one that we just did. So the A goes here, and the B goes here. Okay. So we do negative 5/2, because that is what it says right here, that B equals, plus 4 times the 1/2. Okay, so that is 5 over 2. We don't have to change anything because it's not, the B was alone, so we don't have to multiply by anything like we're going to have to with the A. So that equals negative 5/2 plus, I'm going to put a 1 under here, 4 times 1, 4. 1 times 2, 2. Oh yay, they have the same denominator, so I'm not going to have to do anything about that. But 5 is a negative and 4 is a positive, so I'm going to have to use the different sign rule. That gives me a 1. Since 5 is bigger, it's a negative 1. So this equals negative 1/2. Not too bad, not too bad. Now, let's look at number 8. Okay. It says A, the absolute value of A plus B. A, again, is right there, and B right there. So, the absolute value of 1/2 plus negative 5/2. We have to do what's inside the parentheses first. So we don't want to take the absolute value of 1/2 and take the absolute value of 5/2 and add them together. We're going to want to do what's in here first, and then we can take the absolute value. Okay? So we have, again, this is a negative and this is a positive. So that's going to be 5 minus 1. That gives us 4. Since 5 is the larger sign, it's going to be negative 4. So we have negative 4 over 2. The absolute value makes that equal 4/2, and we know that 4/2 equals 2. And that is our answer. And that is all we have today. Have a great rest of your night, and I'll see you tomorrow.